Let's take up solids. First topic in solids we are taking differences between crystalline and amorphous solids. The first difference is in their shape. Crystalline solids have definite and regular three-dimensional structure, whereas amorphous solids do not have definite and regular symmetrical structure. Second is melting point. Crystalline solids have sharp or definite melting point, that is, they melt at a particular temperature. Amorphous solids do not have definite melting point, rather, they melt over a range of temperature. The third difference is heat of fusion. Crystalline solids have definite heat of fusion, whereas amorphous solids do not have fixed or definite heat of fusion. Compressibility. Crystalline solids are highly rigid and incompressible, whereas amorphous solids can be compressed to an appreciable extent. Fifth difference is cutting with a sharp edge tool. When you cut a crystalline substance, it has regular cleavage. That is, they break into two pieces with a plane surfaces. Whereas amorphous solids on cleavage gives irregular structure. That is, they break into two pieces with irregular surface. Next is isotropy and anisotropy. Crystalline solids are anisotropic. Anisotropic means that they have different properties in different direction, different optical and electrical properties. Whereas amorphous substances are isotropic. It means that they have same optical and electrical properties in all directions. Next, we are defining what is crystal. A crystal is a homogeneous portion of a solid substance made by regular pattern of structural units bonded by plane surface making definite angles with each other. Let's define space lattice. The arrangement of constituting particles like atoms, ions and molecules in different sites in three-dimensional space is called space lattice. Now we are going to define unit cell. The small repeating unit in space lattice, which when repeats over and over again results in the lattice crystal of a given substance, and it is called unit cell. For example, a brick is a unit cell of the wall, because when we repeat bricks in a different fashion, it leads to the formation of wall. Face. The plane surface of the crystal are called faces. For example, in a cubic structure, there are 6 faces of the cube. Edge. An edge is formed by the intersection of two adjacent faces. A cubic structure has 12 edges. Interfacial angles. The angle between the perpendiculars to intersecting faces are called interfacial angles. Now these are various elements of symmetry. One is plane of symmetry. The second one is axis of symmetry. Axis of symmetry can be two-fold axis of symmetry, four-fold axis of symmetry, six-fold axis of symmetry. Then we have center of symmetry, and all of them are called elements of symmetry. For example, a cubic system or cubic crystal has 23 elements of symmetry. Next, we are taking crystal systems. The first crystal system we are taking is cubic. In cubic system, axial distances, that is, or sides A is equal to B is equal to C, means all sides are equal. Axial angles alpha is equal to beta is equal to gamma is equal to 90 degree. These are characteristics of cubic crystals. Let's take up space lattice. In simple, the cubic lattice points are on the 8 corners of the unit cell, and each corner contributes equal to 1 by 8 because each corner is shared by 8 unit cells. This is the shape of cubic crystals, and you will find that the 8 lattice points are on the corners of the cube. Next, we are taking body-centered cubic. In body-centered cubic, 8 lattice points are on the 8 corners of the cube, and 1 lattice point is at body center. Next, we have face-centered cubic. In face-centered cubic, 8 lattice points are at 8 corners of the cube, and 6 lattice points are on the 6 faces of the cube. Next crystal system we are taking is tetragonal. In tetragonal, in axial distance, A is not equal to B is not equal to C. Means all the three sides are unequal. Axial angles alpha is equal to beta is equal to gamma equal to 90 degree. That is, all angles are equal and they are equal to 90 degree. Next, we are taking space lattice. In space lattice, in simple cubic, lattice points are on the 8 corners of the cube. In body center, lattice points are at the 8 corners and one is at the body center. Next crystal system we are taking is orthorhombic. It is also called simply rhombic. Here, axial distance A is not equal to B is not equal to C. Means all the edges are not equal, or all the sides of the cube are not equal. Axial angles are equal. Alpha is equal to beta is equal to gamma is equal to 90 degree. Space lattice, here lattice points are on the 8 corners of the cube and this is simple cubic. Next we have end-centered cubic or side-centered cubic. In this case, 8 lattice points are on the corners and 2 lattice points are on the two face centers opposite to each other. In body centered, lattice points are on the 8 corners and one is at body center. Face centered, lattice points are on 8 corners and 6 lattice points are on the face center. Next crystal system we are taking is rhombohedral. In rhombohedral, all the axial distances A is equal to B is equal to C. All axial angles are equal but they are not equal to 90 degree. In space lattice, we have simple cubic lattice points on the 8 corners of the cube. The shape is slightly different. Next, we are taking hexagonal crystal system. In hexagonal crystal system, A is equal to B but not equal to C. That is, two sides are equal but not the third side. And axial angles alpha and beta are equal to 90 degree, whereas the third angle gamma is equal to 120 degree. Space lattice, there can be simple cubic in which lattice points are on the 12 corners of the unit cell, outlined by thick line as shown in the diagram. Or lattice points are at the 12 corners of the hexagonal prism and at the centers to the two hexagonal faces. Next crystal system is monoclinic. In monoclinic system, all the sides are unequal. That is, axial distance A is not equal to B is not equal to C. Two angles are equal, alpha and beta, they are equal to 90 degree, but it is not equal to gamma. That is, gamma is not equal to 90 degree. Space lattice, we have simple cubic, lattice point on the 8 corners, end centered, lattice points at the 8 corners and at the two face centers opposite to each other. These are the diagrams of this monoclinic system. Next crystal system is triclinic. In triclinic, axial distance are unequal. That is, all the three sides are unequal. A is not equal to B is not equal to C. Axial angles are also not equal and they are not even equal to 90 degree. Space lattice, we have simple cubic in which lattice points are on the 8 corners of the unit cell. This is the diagram of triclinic crystal which is cubic.